Hi, Binary Viking here, and I'm back with another tutorial on C#, and let's fast delete that. So, last episode I talked about properties and how we can use them and change it so we can get it, but we can't set the value, or we can get the value, but we can't change the value outside the class. And as you can see, I've changed a bit up. I added a property to height and a property to weight. And I up here changed it to private. These fields as it's called. And the reason why is so we can change this outside the class. We also have here the first name, last name, which have the standard properties or getters and setters, which is essentially equal or the same as this right here, as I told in the last episode. So last episode I talked about how we can use properties to define or use properties to say that a value should not be over or under a certain amount or anything like that when we set the value or for instance get the value. And the way it works is we can in here say if value is, now let's see if it's over, let's say 1000, because no, actually it's turned wrong like this, because no human being should have a weight or possibly have a weight over 1000. If you know any, I'm sorry if I offend you, but I don't believe anyone in the world have a weight over 1000 kilogram. So, and this we had right here is or, so it's pretty much if it's over or if it's, say, under 5. We can do something about this value. We can, for instance, say, okay, so maybe I should actually, before I go any further, I should probably explain the if right here. So if is pretty much a control word, if you want to call it that, where you say if value, and value here is a parameter that we can't actually see that we get or we have when we set a value. It's pretty much the same as down here if we had this one, so it's pretty much this one we get as value up here. So we say if value is over 1000 or if value is under 5, we can do something about the value in here. We can, for instance, say console right line, say value is invalid. That is one way of doing it. We can also do something like else if, oh, excuse me. We can also do something like else if, where we say if instead of having or up here, we can have this down below to be like this. Do something like this. We can then up here say value is too big. We can down here say value is too small. We can also, in cases like this, even go down and say we want to throw an exception, and this is a runtime exception, and it's just called exception, and we actually want to throw a new exception and say, we can pretty much copy this if we want to. Be lazy, of course, and I am lazy. So we can do like this and have it up here as well, and change this to big. So now, if I was to change weight to a value higher than 1000 or lower than 5, actually I should probably change this to 2, because babies can't or can have a weight that is possibly really low. So if I, for instance, was to change this to something really big, we should see in the console it will first write values to big, and will then have an exception right here that is unhandled. That's because we throw the exception, but we do not catch the exception anywhere. We can even see here it have written values to big. So how do we handle exceptions, you may ask? And the way we normally handle it is to make a try and then a catch, and in some cases we also have a finally. So the way this works is pretty much this will always happen. So it pretty much try to do something. If it fails to do that, we go into catch, and we also in here can directly say what it should catch. We can, for instance, say catch exception, and this is a parameter, so it will catch an exception ex. And we can then here say console dot write line and say exception dot message, for instance. And we down here can say console dot write line, and we could down here do something to check or actually find out if the person have been made correctly or change something, or if anything should happen regardless of something, or regardless of there was an error or it was actually successful. I can't see what exactly we could have right now, but just remember finally will always happen. I rarely use it myself, but if we do like this, we can see, oh yeah, right, the value, you can see here the value is too big, and it afterwards right down here. Oh, sorry about that. Oh, okay, so we should also move this up here, as if the person fails to be constructed, we can't use person.get full name or person.get BMI, because the person will be null. If at any time an object fails to be constructed, it will simply be null. So if I go in and remove this one, for instance, we can go in here and compile it. We can see now it's printing out the message we get from the exception, and the message is this one right here. The value is too big, and it will then go through here. If there was anything in there, of course, it will go through here, and lastly go down to read key, and when I click a key, it will of course close. We could do the same for height, but I think it's clear, or somewhat clear here, to see that how it works, or how you can use properties to limit a value. We can even change this to 1, and you will see again value is too small, and of course it prints 2 times because it's also printing here. If I remove this, it will again only print 1 time, as we see here, and the place it prints is right here. So it's a great way to limit or make sure your value have a defined span, so it does not change to, let's say, something that is not expected. For instance, if you want a progress bar or something, you would never have the progress to go over 100% at the most, or most time you won't have it to go over that. So you could, for instance, instead, if this was a progress bar, you could change this to 0 and you could change this to 100, because it should never be higher or lower, higher than 100 or lower than 0. And if it is that, of course there is something wrong, and it will then throw an exception. What you normally would do is to somehow handle the exception. For instance, say, okay, something is wrong, we should do something about this, or change the whatever there seems to be a problem. So for instance, we can say, okay, the person did not do correctly up there, or be constructed correctly up there. And this is of course only for practice show. So I don't even know, but we could make a default person that we always know works like this, and put it up, but you probably would do something else to handle the exception and change the value. That seems to be a problem, probably. So in this case it would only be the weight if we did not have this. So I think that is it. I do think I have time to show a bit more, and what I want to show now is, I will first change this to 6T like this. And I think I will show a bit more, and what I want to show is some loop types. In most programming languages you have 3 loop types, if I'm correct. Actually 4 in some cases. But you have for loop, which consist of 3 things usually. You have an int, and let's call it counter, just to make it simple, equals 0. You then want the counter to be something like this, and you want to increase the counter by 1. So plus plus is the same as saying plus 1, essentially. Plus plus increases the value of a int by 1. So we can, for instance, do something like this and say we want to have the person printed. Let's just copy this one actually. We want the person to be printed in the console 10 times, as we see here. So if I go up here, say run, we have now printed the person 10 times. I could, for instance, change this to be equal 5. They would only be printed 5 times, of course. I could even change this to say I only want it to be printed, or this to go into counter is equal to 6. So like this. We only have it printed once because counter is equal to 5 already. I could, I could of course always change it back. I can change this to anything. It's pretty much equal to have a int out here. I, for instance, just to simplify. This is pretty much the same. I could even have the I to stand right here, if I'm correct. Oh, I actually need to define it first. So I could do like this, for instance. Counter is not defined anymore, so it would be I and I. But usually you only will do it like this and have it all in the same line. And yeah, that is the for loop, and that is probably the most used without being entirely sure. So pretty simple. And we can see here the way you usually will read it is set a value as long this is true, do whatever is inside the body. Whenever the body is finished, do this. And we could even do some pretty crazy stuff up here. We could say, could for instance even say person equal new person blah 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 blah. Let's just say do something like this because I'm lazy, and say I plus plus, if I'm correct. Oh right, you can't have more than one code line up here. I forgot about that. So you can have one code line up here to do whatever you want when the loop is done with whatever that is inside. Usually you will use it as shown before to count something like this. Oops, not like this. The next one is pretty similar but a bit more simple. It's a while loop, and what you have here is you actually need to define something outside for the most part. Int I equal 0, for instance. Let's fast comment this out. What you do here is saying while I is less than 5, for instance, do whatever is inside here. What you need to do here is to make sure self do whatever you want to do with I inside the while loop. So for instance here we need to actually increase the I value inside the loop rather than at the for loop where the value was increased every time the loop stopped. But here, as we can see, we need to do it the other way, or inside the loop. If we didn't increase it, this will always be true because we can the I is not changed anywhere, and what this leads to is a messy console like this. So it will keep on printing or writing the line non-stop. So inside here you will need to increase or change the ball. Well, it depends on what you want to do, of course. Sometimes you do want to have the loop run forever or do something forever. Networking, for instance, is a good example where you would have the loop run forever to listen to clients connecting, for instance. More about that in a later episode, probably. Yeah, so the next one is do and have a while below it. And this one is a bit different. It's probably also one of them that is rarely used, but is actually a great one to have sometime. Regardless of whatever value or what happens, this will always be ran at least once. So of course it will still be ran 5 times here, as we can see here. But let's for instance say that here we can see now, and we will not even change the I, we just say do this and keep on doing it while I is lower than 0. So we can see here it will do it once, even though this down here is false. The last one is a for each loop, and for each is a bit different. You usually will use for each in some sort of array or collection, which I will talk about later on as well. But what for each will do is it will go through every single object which is inside a collection or array, and when it have gone through every single object inside the array or collection, it will stop afterwards. I hope you find this tutorial somewhat useful. If there's any question, feel free to ask them in the comments. I will try to answer them as best as I can. If there's anything I should change, or you think I'm going too fast, too slow, feel free to tell me or give me feedback in the comments as well. I try to do my best and really go in depth, so even new programmers or people that have never programmed before can understand and get the point I'm talking about. So thank you very much for watching. Take it easy and happy coding.